In this video, we're going to talk about isotopes and what isotopes are and the difference between isotopes. So let's look at an example here. On the left side we have carbon 12 and on the right side we have carbon 13. Now what do these numbers mean? Right here, I erased it. These numbers. The number on the top is called the mass number. The mass number is equal to the number of protons and the number of neutrons added together. The number on the bottom is the atomic number, or Z as we call it, or write it. And it is equal to the number of protons. So for these two examples, go ahead and figure out the number of protons and neutrons for each. So on the left side we have 6 protons because our atomic number is 6 and that's equal to the number of protons. In terms of neutrons, we can figure out the number of neutrons using this equation. So if the mass number is equal to the number of protons plus the number of neutrons, then we can subtract both sides by the number of protons and we get the mass number minus the number of protons, or the mass number minus the atomic number. So in this case, on the left side, our mass number is 12 and our atomic number is 6. So the number of neutrons is going to be 6. On the right side, we have 6 protons and we have 7 neutrons. So an isotope is going to have the same number of protons, but it is going to have a different number of neutrons. Now, the number of protons also determines the element which the isotope is going to be. So, if you see 6 as the atomic number or the number of protons, it's always going to be C. It's always going to be carbon. And you can figure that out by looking at your periodic table. Every element on the top has a number, and that is going to be its atomic number. And that's going to determine the number of protons that it has and which element it is. Now, let's look at a different example. Let's say we had these elements. Are these elements isotopes or are they not isotopes? These elements are isotopes of each other. So the first example on the left, the atomic mass is equal to the atomic number. The mass is equal to the mass number is equal to the atomic number. What this means is that you have the same number of protons as, it doesn't actually mean that. It means that you actually don't have any neutrons at all. So you have 1 proton and you have 0 neutrons. In the middle, if your mass number is twice that of your atomic number, that means that the number of neutrons and protons are equal, because it means that half of the things that are in the nucleus are protons and the other half are neutrons. In the example to the right, we have once again 1 proton because the atomic number is 1 and the mass number is 3, so that's 2 more things, so that's 2 neutrons. Now these are isotopes of hydrogen, and the names of these might be important in your chemistry class. So the first one is protium, and then you have deuterium, and then you have tritium. So make sure you remember those for your class. Now let's go through a few more examples and try to determine if the two elements I'm going to show you are going to be isotopes of one another or not. So take this example. Are these two elements, or these two examples, isotopes of one another? The answer is no. The reason it is no is because the atomic number, which is going to be on the bottom always, is different. If the atomic number is ever different, that means that they're not going to be isotopes. Let's look at another example. Are these going to be isotopes of one another? Once again, they're not going to be isotopes. Even though their atomic number is the same, their mass numbers are also the same. The mass numbers need to be different, so they can't be the same. If they're the same, and you also have the same number of, what is it called? Same number of protons, then they're just going to be the same exact atoms. They're not going to be different isotopes. Now, the letters which I'm putting are just random. They're not from the periodic table. If you were to forget the letter of the element, would these be isotopes of one another? These would be isotopes of one another because they have the same number of protons, which is 27, so they are going to be the same elements, and they actually have different numbers of neutrons. So the one on the right has 9 neutrons, and the one on the left has 8. Let's go ahead and work on these questions. Write the atomic symbol for each situation. So before we get started, let's think of the guideline that we're going to use. The number on the top is always going to be the mass number. That's going to be protons plus neutrons. The number on the bottom is going to be the atomic number. That's always going to be equal to the number of protons. And then the letter is going to be the letter of the element that you're going to have to go to the periodic table to find. And I just wrote A as an example, but they're going to differ for each situation. So let's look at the first one. We have 7 protons and 7 neutrons. If we have 7 protons, that means that on the bottom we will have 7, because we have the atomic number. And if we have 7 neutrons, we're going to add that to the number of protons. So that's going to become 7 plus 7, or just 14. And then go ahead and find which element on the periodic table has a 7 on top of it. It is going to be nitrogen. So this is going to be nitrogen 14. Now keep in mind that in the periodic table, it's actually opposite. You will have the atomic number. We have it written in the bottom here, but in the periodic table, it's going to be right on top of the elements, or the element's letter. Number 2 is 14 neutrons and a mass number of 25. So for this one, if the mass number is 25 and we want to find the number of protons, we're going to have to take 25 minus 14, which is going to be 11. So that's going to be the number of protons. And that's going to be equal to the atomic number. So we're going to write it on the bottom. And we know the mass number is 25, so we can just put that on top. On the periodic table, the element with 11 protons is going to be sodium. And sodium's written as Na. So it's going to be sodium 25. The next example says the atomic number of 17 with 18 neutrons. The atomic number is equal to the number of protons, and the atomic number is what we put on the bottom. So we're going to write 17. The number of neutrons is 18, and in order to find the mass, we need to add that to the number of protons. So 17 plus 18 is going to be 35. And the element with 17 protons is going to be chlorine. So this is chlorine 35. Number 4, we have 11 protons and a mass number of 23. So we know that we have 11 protons, so we're going to put that on the bottom. And we have a mass number of 23. And on the top you put the mass number, so we're just going to put 23. And once again, this is going to be sodium. So this is sodium 23. In order to review, let's go through the following true and false questions. The atomic number is equal to the number of protons. That is a correct statement. That's true. The mass number is the sum of the number of protons and neutrons. That is also true. Isotopes are composed of the same element. They are indeed composed of the same element. Isotopes share the same atomic number. That's true. Isotopes share the same mass number. Isotopes do not share the same mass number. Isotopes have the same number of neutrons. They actually have different number of neutrons, which is why they have a different mass number, because the mass number is the addition of protons and neutrons. So if you're going to have a different number of neutrons and the same number of protons, your mass number is going to differ. Isotopes differ in the number of protons. They do not. They always have the same number of protons. Isotopes possess different chemical, it should say properties. That is incorrect. They have the same exact chemical properties. Isotopes possess different nuclear properties. They do possess different nuclear properties. So their decaying and stability in that sense is not going to be the same, but they're going to react the same way as they would if they had a different number of neutrons. Isotopes possess different number of electrons. So this is false. Isotopes are always going to have also the same number of electrons. So if you ever see something like carbon 12 and you have like a +1 charge, that's not going to be an isotope of this because they don't have the same charge. So that's all you need to know about isotopes. Thank you for watching.